have to think this out. You have to see what's missing, and you have to think out what you have to solve for. So in the first one, I could take the log of both sides and try to bring that down. I could probably try that. But if you can see that you can drop 64 down to a base 4, set these equal to each other. Good. Sometimes they flip to exponentials. If this was something that couldn't go down to a base 4, and it could go down to a base 2, like if this was a 32, you'd have to bring this guy down to a base 2 as well. Right? To the first base that they can both come down to. The E, probably best to isolate this, otherwise you're going to have to do an ln and separate it as a multiply. So divide this, make life easy. No? Somebody say something? No? Okay. Take the ln of both sides. If you took the ln of both sides right here, you have to use your product rule. Not a bad deal, bless you, not a bad deal. You can still use your product rule. Okay. Another way to check these two, I wrote this off to the side. Anytime you have a y and a y, put them in your calculator just to see if it intersects where you thought it was going to intersect. y1, y2, see where they intersect. So it's a nice way to check it. Sometimes, if they don't look solvable, try them on your calculator first. That might help you like back out of this a little bit. And again, 3 decimals. Give me 3 decimals. I probably went to 4 there. Give me 3 decimal places. Stop me if you have any questions. Okay, so let's see. I should have done this from the very beginning. Still doesn't like this. Okay. This one, you have logs on one side. You cannot cancel them out. You cannot put a log on the other side. So this is where you use log equals exponent. Or, oops. There's always something new with this board, isn't it? No, I'm trying to make it bigger. Okay, better? This is where you do log equals exponent. Or if you do back or whatever it is you do, flip it from the bottom, raise it, equals. That's another easy, very easy way to get through this. That's my way. Start the base, go up and over. So flip this to an exponential and it solves very nicely. You cannot take the log away, and you cannot put logs on both sides. When you have log on one side, you're going to flip it back to an exponential equation. So there's different kinds of equations you're going to use. This one, I think it just said find the point of intersection, so you're just going to set them equal to each other. Algebraically, you just set them equal to each other. So drop this down to a base 2. Take the log of both sides if you like. You can do it either way. Either way is fine. Just take the log, bring down the variable. That works. Same thing with the other one. Try to get rid of that 4. Anything in front of your logs, just see if you can divide by it. If it divides evenly, fine. If it doesn't, you can even keep the fraction. Flip that one. It says 243. That's because it is 243. Thank you. Feel free to correct me at any time. Good? Process good here? Check them on your calcs. See on your calculator if it's really doing an intersect there. This is another good one to check on your calcs. Anytime you can always put a y1, y2. Sometimes you get these really weird answers and you say, this is possible. You can always substitute them back in because they work very nicely substituted since you have that log calculation thing too. You can always substitute them back in, or you can always check them in your calculator real fast. y1, y2. Okay, let's put all these in. All right, again, if it's just nice an exponent. With this one, I tend to like to get rid of my fractions. I'll flip this one first and make it the -1. The -1 is what makes you take the reciprocal. So bring it back to a -1 and then do it. If you like to do this as 7 squared first and then flip it over, that is fine with me. Whichever way. I tend to flip my fraction first and just get the -1 out of there. And then again, don't forget, try it. Just plug it in your calculator, 7 raised to the -2. You can probably do that right in your head. This one, if you could create this one, something like that too, then you're good to go. Okay, so x is equal to 3. This is your 3 to the third. This is your 4 to the third. This is your 3 to the x. This is your 4 to the x. We're good? Stop me if you have any questions. These are all different types of equations. Again, log on one side, you have to flip this to an exponential equation. You can't cross out your logs, you can't add a log to the other side. So 10 to the -1, and if you left your 0.1, that's fine. Again, 10 to the -1/2, 3 decimals. ln e, this cancels out. This guy's going to come down here. It's just an expression. This didn't have anything to solve for. Was that one confusing? Yeah.
I just flipped it.
Yeah, no, that was it. I probably did. I'm not sure if it had the same explanation on top. I should check to see if it did. I kind of like the problem, so I just stuck that in there, but sorry about that. All right, what do we got here? Again, ln e cancels out no matter where it is. This guy. Now this one's a little tough to find because we can't drop this down to a base. So therefore we're going to take the log of both sides or the ln of both sides. Doesn't matter which one you do. Then you can bring down your exponent. You need to get x by itself, so you're going to divide by this. Now if you use a fraction bar, this works fine. If you don't use a fraction bar, make sure this is in parentheses. Otherwise, when you put this in your calculator and you divide this, it's going to do ln of 360 divided by 3, and then multiply it by ln of 8. So if you've got the 83 calculators, make sure those are in parentheses. This one, I divided by -2 just to get rid of the fraction. Do you have to? No. Can you divide by a -1/2? Absolutely. One thing to remember, these don't get changed. The log of 0.2, the log of 8, you're not changing those. Whatever you multiply is multiplied out in front. Questions? I know kids don't like those negative exponents, nor do they like the fractional exponents. Good? All right. I can't complain about my board. At least I have one. That's right. I did tell you I went to that board meeting where they talked about those new boards coming in, right?
The board meeting.
The board meeting. Yes, that was good, Lane. I like that.
Board like smart board. Yeah. I don't know. Just making sure.
You can use LN for anything. No, you have to use it for an A, but you can use it for anything. That's why I said most college books you're going to see always use LN. No, it comes out the same way. The natural log is a log. It still is a log. It's just a special case. And it falls right between a 2 and a 3, a little closer to the 3, but it is a log. So you have to use the ln with the e. No, most college books just only use ln just because. Why not? It's there. It's easier. Yeah. All right. So now we get a little bit confusing here. So we're going to get rid of the 13. We're going to get one term. We're going to get rid of the 5 because we can't take the log. Well, you can take the log, but then you're going to use your product rule. If you take the log right here, you're going to use your product rule, right? Did anybody do that and use the product rule?
Wait. I didn't know how to do it.
Okay. Did we get through this step?
Yes.
Okay. Did anybody take the log of both sides here? No? Because if you take the log of both sides, this is a product, and you'll do log of 5 plus the log of this mess, which is probably the right way to do it. But we can divide by 5 and leave this fraction. Don't reduce this. When we come down here, the only thing that's going to bring this exponent down is a log. So we take the log of both sides. We bring down the exponent. Okay, keep that fraction there. Now, do this in 2 steps because this has to stay like this right now. So get rid of the ln2. Divide by ln2. It looks a little bit messy, but we keep it like this because that's a fraction. We don't want to reduce that. It'll come out as a decimal. If you reduce it to a decimal, I'm fine with that. If it was divided by 3, you'd have to keep it a fraction. I mean, if you kept yours as a decimal, not a big deal. I just tend to keep fractions. When we reach this point, our goal is to solve for x. So if we subtract 3 from the other side, we're left with negative x. So to get rid of my negative x, I divided by -1, and therefore that flipped the signs over here. So kind of messy looking. This would be my exact value if I put this in my calculator and get that. And again, plug it back in. It's really nicely to plug. It's an exponential equation. Just plug it back in. Just in your regular calculator, 5 times, and make it look exactly like this. 2, and raise this to the 3 minus -1.498. And then come back out of this and see if it's equal to close to 100. It won't be exactly because you rounded. No, you can use log. Yep. Log and ln are both logs. The ln is just the natural log. The ln has to be used when you use an 8, but you can use it either time. So I tend to use ln and switch them off a little just so that you can see where they are. You can use ln all the time, so you never have to use the word log. It is a log. It's just a natural log. Okay, this guy, a little bit messy, but this is one thing going on here. This belongs to this whole thing. So you're going to take the log of both sides first, and then you're going to bring down that piece right here. And then work it out one step at a time. This does not get separated. If you wanted to add them together, that's fine. But try to keep it as, unless it adds together nicely and terminates, that's fine. But this one doesn't, I don't think it terminates. So this one we have to keep like this. Your goal is to solve for t. So it's being multiplied by this and this mess here. And again, if you have the 83 calculators, this will have to go in parentheses. If you have the alpha key, not a problem. This makes sense? Good? Okay, stop me if you have any questions. I'm sure this next one was a question, right? Okay. So if it was like this, you would factor this, right? If it was like this, a quadratic, I would say x minus 5, x plus 1. Now, when I do this one, I add my exponents, right? So it's the same as taking whatever this is and just dividing it in half. If it was x to the 4th, this is kind of my key right here, isn't it? Isn't that kind of my key? Because when I divide this in half, isn't it this guy? Because this is the one that I add together. So this would be x squared, blah, blah, blah. So the same thing here. This I'm just dividing in half. 2x divided by 2 is e to the x. This is the guy I'm adding that middle term. If I add that middle term, he's got to be over here, right? So if I split this in half, I get e to the x, and it factors just like you would normally. Make sense? Okay? So then we set both of these equal to 0 and solve for both of them. Now remember, we have to check for validity here. Our domain says 0 to infinity. We can't take the log of a negative number nor the ln of a negative number, and we can't take the log of a 0. So when we come down here, we're forced to take the log of a negative number. We can't do that. So we reject it. And then this would be my answer. Okay, I graphed it because isn't this the zeros of your equation? When we follow the quadratic, we set it equal to 0. We find the zeros of your equation. When y is equal to 0, isn't this your y, right? So on your graph, we can find that point also. Well, your y is 0. It only has one. The other one we reject. It's a non-real one. We can't do that one. Make sense? That was a little challenging. That was a little bit of a thinker. But key to this is this guy right here, because that's what you're adding up, your middle term, right? So those have to be there when you add them up, no matter how bad that first one looks. This guy, that's what this is going to come to be. If I did x to the 8th, and this is something x to the 4th, where is my x to the 4th? Because I divided this in 2. Okay. All right. I don't know where this came from. All right, you have an ln here. You can't get rid of the ln, and you can't add ln to the other side. It's just like if I had the word log there. For an ln, though, my base is e. Flip it back to an exponential equation. For a log, when I don't have a base, what is my base? 10. When I have just the word log, if you had to flip this, and there's no base, it's 10. When I have an ln, my base is e. So e to the 2.1, and you can do this part in your calculator. Just divide by 4, put this whole thing right in your calculator, and round to 3 digits. This came from somewhere, I'm not sure where. But something happened to my document. What happens, oh, it came from here. What happens is this word is a different word than I used, so my whole thing gets messed up. Only with the new word. With the old word, it didn't do that. With the new word, it's killing me here. All right. I apologize for that. Because I don't see this on my computer. It doesn't do this until I do it here. I must have a really updated version over here. All right, so let's take a look at this. What did these directions say?
There were none.
There were none?
No.
So you just had to solve. Okay. So somewhere in here is this answer. 103? Okay. So now 10 to the second power is equal to z minus 3. Okay, you're going to add 3 to both sides. 10 to the second power is 100. We're good? Now, the reason I wrote this up here, this is where your domain comes from. This is where your domain is. So, same thing we did before with restricted domains, we can do with this one. If our domain says from 0 to infinity, our domain technically says x has to be not equal to, but greater than 0. So if you take this out and you set this greater than 0, your domain has to say z is greater than 3. If my answer comes before 3, then I know I can't use that, right? Because when I plug it back into here, it'll either give me a 0 or a negative number. This didn't say find the domains? Okay, so probably I left that out somewhere. All right, so this is a good thing for us to go through right now. if we're looking for what the domain is for this equation, we'll talk about the equation in a minute. If we set each one of these greater than 0, and we solve, x is greater than -5, x is greater than 1, x is greater than -1. What does our domain have to be if we have all three of those? Here's my line. Guys, you with me back there? Here's -5. Here's -1. Here's 1. One of them says this, one of them says this, and one of them says this. What is my domain? X is greater than 1. It has to be this one. Because if I use a -1 in here, what happens to me? I get a -2, right? I can't do this one. If I use a -5 in here, can't do it. If I use a -1 in here, there's my 0. So somewhere along the line, you're going to have to figure out, if I ask you for your domains, you're going to have to just do it this way and make sure you do this. Could you graph each one? You could. A little longer, but you could. Let's take a look at the log if you could see it. I don't know where this all came from, this red, but somewhere. Now, you have logs all over the place, right? So you want to come down, in order for you to take them away, you have to say log equals log. This has to come down to one statement. Once you get that statement, one term, take your logs away. And then solve it like a regular equation. I cross-multiplied it. You're going to get them down to a quadratic, factor it, and you're going to test it. Now, when x is -3 and -2, do they work? Mm-mm. Can you read this? Okay, I'm sorry about all this writing in between. Again, I don't see it on my computer. I only see it here. What part? Did we get this far? Where you got log equals log? Okay, because that's the important part. Log equals log is our log part. This part is our algebra part. Cross multiply these guys, multiply this, get everything to one side, and then factor. Be careful of your factors. You want them to add up to 5 because everything's positive. And then you can say no solution. I don't know where my no solution is. This one, here's another good one. This one has logs on one side and logs on the other side. Bring this down to one log. Only when you have one term, you can cancel out your logs. Set these guys equal to each other, cross multiply. This one was kind of messy. Yeah, but did you get this far? No?
No, I got x equals 1/2. I don't really know how.
Okay.
It's not.
Can't be because you have an x squared here when you multiply this times this. This when you cross multiply this guy's going to give you an x squared. So you're going to get a quadratic that you have to factor. Now you have two choices. You can complete the square, or you can use the quadratic formula. Okay. Complete the square means this has a half. This is coming out with a half one. So I use the quadratic formula, and again, we have to reject the -1 because it's outside the domain. The domain again, x plus 1 greater than 0, x minus 2 greater than 0, so x has to be greater than -1, and 2, so therefore x has to be greater than 2. And if those are not, then we have to reject them. But the plus one seems to be in our domain. This one had just a little twist in there because you couldn't factor it. Well, you can, but you just have to do a little bit more work. I agree, this one was probably hard. Longer. Not harder, but longer. Are we okay with these? I think this is where my domain 2 came from. I don't know why it showed up over here, but I'll have to upgrade my wood. Alright, let's take a look at this. Ah, this probably drove you crazy too, huh? Did this one drive you crazy? This is because you're honors. I give you these.
I did not know how to do this.
Okay, so let's before you get to this, what am I going to do with this guy? I only have logs on one side. What happens when we have logs on one side?
You gotta take them away.
You can't take them away because they're only on one side. You're going to flip it to an exponential equation, right? Like log, it looks like one of these. Logs on one side, you're going to flip to an exponential equation. But I can't do that yet until I combine these two. Because I have to make it one term, one term. So now I can flip it to an exponential equation. What is my base? E. E to the 1 is equal to this mess. So, okay, leave this here for a minute. Distribute this, subtract the E over here. Okay? So now, when I do this, it's going to come out. I'm going to have to follow this through because I have no clue how to factor this. Right? I have no idea how to factor this with the E over here. So I use the quadratic formula and I work my way through. It's just kind of following it through the quadratic. Yes. Okay, so if I had this. Let's get the LNs out of there. Right? I have logs on one side. I got to get it down to where it says log equals something. I got to condense it down. So when I was adding exponents, what was I doing? Multiplying. So I'm going to bring this down to a product. Good so far?
Yeah, I know you have to multiply. I just don't know where you brought the E.
Oh, okay, so forget the natural log first. So this tells me 2 raised to the 1 is equal to this, right? Agree? Okay, so now, I have no base on this. No base. So I still have to do the same thing, right? I'm going to condense it down. And it's going to look like this. What do I do with this guy? How do I flip this to, this is a 10, right? So now I can 10 to the 1. So same thing here. I bring this down, I condense it. You agree to condense, right? When you get down here, how am I going to flip this? What is my base? My base is E. The two missing ones, ln has an E. Log by itself has a 10. And I got to tell you, I have so many kids that stare at this when there's no base and say, how do you want me to flip this? There's no base. Right, because ln is understood to be E, log by itself is understood to be 10. We work in a base 10 system. So ours is automatically base 10.
What did you, for the, put it in, why didn't you just do negative 3 squared minus 4 1 negative 8? Why did you do like all this stuff?
I factored out the 4 because it was factorable. I factored out the 4, so then I took the square root of 4 times the square root of 1 plus 8. The square root of 4 was 2, so I got a 2 out of there. Then I factored out this 2, crossed that out. Sure. Negative E, I put in negative E, but this times this made this become a positive because of negative. So I got to here, then I factored out a 4 underneath the radical sign. Then I said you can take the square root of 4, right? Because these are two things. If you had this, what would this reduce to? Guys, what would this reduce to? 2. Okay. So I did the same thing here. 2. Do you have to do all that? No, you're going to stick it in your calculator anyway. Do you have to do all that? No, because you're going to stick it in your calculator. If you just get to here, can't you stick that in your calculator? Absolutely. I just reduced it all down. Remember, I just always do a little bit extra just in case somebody did that way. Or you left it like this, which is your
How'd you get to that? Yeah, I don't understand.
how did I get to this?
Yeah.
I did your quadratic formula.
Yeah. I know that. But how'd you get to the two different radicals for one
I just factored out the 4. I factored out a 4, so this looked like this. No, this is not together. These are separate. This there came to this, then it came to this. So then I brought it down here, factored out a 2. I reduced it as much as possible. Do you have to? No. If you're going to put this in your calculator, stop right there. This should be doable. And then put that in your calculator. You're going to go 3 decimals. If you need exact value, you have to come down to here. But because you can go 3 decimals, you don't have to reduce it. If this was a regent and it said, find the roots to the nearest 100, and you had something that looked as bad as this, and it said, find the roots to the nearest 100, I say, should I reduce this? This probably has a perfect square in here somewhere, right? Do I care if I'm going to the nearest hundreds? No. Then I'll just put this in my calculator, right? So the same thing here. If you're going to come down to 3 decimals, do you care? No. I just kind of do this because I reduced. And if you had to find the exact value, these would be your exact values. But my point in giving you this one is, yeah, it's kind of ugly looking, but you're using the quadratic on it. It falls into your quadratic formula. This was nice because, again, combine your logs on one side, flip it, and get everything to one side. I see an x squared. I can only do the quadratic or something with my x squared or factor. So I bring my e over, and I'm like, what do I do? What do I do if this said 5? I do my quadratic, right? Because I can't factor it. So I do my quadratic. It's not going to be pretty, but you also have a calculator to resolve your e. E is a number. 2.7178 something or other. It's a number. It's our natural number. I wouldn't give you this on a test. I won't give you on a test, but as an honest, I expect you to try it, right?
I tried it, just was.
Yeah.
The one down to the right. How'd you get that?
So this, I factored out a 2. Could you also just separate this? Yeah, I just factored the 2 out of the numerator and then canceled out my denominator.
Where'd you get the one?
Because then 2 divided by 2 is 1. This one I don't need a 1 because I have this factor here. I could put a 1 here if that is better. But remember, when you factor out, if the factor is 1 and it's a term by itself, then you have to put the 1. All that was your quadratic. Here's your new light to your quadratic formula.
Is there a way, like, I just put everything under the radical, like, I just put it in the calculator and then solved it with that number?
That's fine. That's what I'm saying. If you get here, that's fine. Because
so, like,
you're...
I didn't even separate it. Like, the b squared minus 4ac, I put that, like, thing in the calculator, and then I had, like, 2 plus or minus the square root of that number over 2, and then like this.
All right. That's different, and it still worked out okay?
Yeah.
Okay. Sounds good. Good. I mean, you don't have to work it out as much as me. Remember, I work things out all the way through. But if you're going to find me 3 decimals, stop wherever you're comfortable. As soon as, like Allie said, as soon as she plugged them all in, she put it in the calculator, and that's fine. You're coming out with 3 decimals. Same on a Regents question. If I gave you this on a Regents question, and I say, give me, to the hundredths place, 2 decimals, do you have to resolve this radical? No, they don't care because they want your 2 decimals. Yeah. These should be your challenging questions. This guy, again, bring it down to the same base. You got logs on one side. You get 3 types of equations. Logs on one side, logs on both sides, and totally exponential, and you have to put the logs there. So again, when you get down to this part right here, what do? I have only logs on one side. I can't cancel my logs. I have to flip this. This is my base E. E to the 10th power equals this now. And again, if you distribute it and throw that in there, don't ask me what I did here.
Yeah, what is that?
This is E to the 10th power.
Yeah, and then I didn't know where to go from.
Yeah, you could absolutely leave that one there.
Okay.
Yeah, because you can't factor that. And if you did this, you would have to do the quadratic with E to the 10th power in there.
Do you know when the emergency is?
When is Regents Week? It actually is the last day of this month. The 31st. The 31st. But Regents Week is the last week of this.